All right, well, welcome to Lecture 2 of CS193p of Spring in 2025. So today we're just going to be continuing all demo all the time. We learned about views last time, and today we're going to learn about something called view modifiers, the other major pillar in the building of our UIs. And then we're going to dive right into starting to build our CodeBreaker. And I'm not going to get back to the slides, so I'm going to show you one more slide, which is just to give you a preview of what's going to happen next week, which is that we're going to learn about how in SwiftUI we separate what we call the model, which is like our gameplay logic or our data, if we have a database behind our UI or any of that, from the UI proper, which was what we've been looking at so far this week. And I'm also going to be showing slides, next time, and talking more about things like struct and generic types, optionals, extensions, some of the kind of basic stuff that you'll be reading about in your reading assignment number 1, but I just want to emphasize some of the stuff by actually going through it in slides. You'll get an idea of what things are really important by the ones I cover in slides versus the ones from your reading. Let's head back to Xcode. This is where we left off last time, and I'm actually going to take just 2 minutes to summarize everything we did in last lecture in like 3.5 minutes, okay, or 3 minutes, just to make sure that as I explain it again, you're like, yeah, I understood that, etc., or not. And first, I'm going to clean up some of this, remove that little if-then we had in our view builder there, for example, just to make it a little simpler as I go through this explanation. Okay, so what did we do last time? Well, we made a helicopter view, right, called content view by creating a struct that behaved like a view. And we knew that if we want to make a struct that behaves like a view, we're going to get a lot of cool features, which are the things I'm going to go over today, by the way. But we also had a responsibility. If we want to behave like a view, we have to do this one thing, which is to create this var in our struct called body. And that var's type has to be something that behaves like a view. And we learned from our little Lego analogy, this is how we build bigger and bigger views, is by just combining other views. Now, this var body is a computed property, right? We compute its value every single time we ask for it. We run this code in the curly braces right there to get the value. And so, again, var body is trying to get some view. So what some view do we return here? Well, we return an instruction manual view, which is currently a Z stack here, but I'm going to change it back to being a V stack so we can see all our views. And that instruction manual view right there had 3 arguments: alignment, spacing, and then this third argument, which was its content, and that argument was of type function. Now, we don't see those first 2 arguments because we're taking the default alignment and spacing, so we don't need it. But that third argument, the content, is there. It doesn't look like a normal argument, and that's because we learned that if you have a function or a creation of a struct like this, and the last argument is a function, you get to just drop it off the end like that. And we also learned that if you do that dropping off the end, and your function or your creation is left with no arguments, because we don't use alignment and space, that you can leave that off as well. That's the only time you can leave those parentheses off, when you have this function hanging off the end. So this function that's in our third argument to our VStack right here, this is returning the view that the VStack is going to arrange vertically. That's why it's called a VStack. This particular view is a bag of Lego view built by @ViewBuilder. And you don't see @ViewBuilder on screen. I showed it to you on Monday, but it's there. It's on the argument to VStack, that third argument. You remember, it said @ViewBuilder content. So we have a view builder there, and we're just listing 4 Lego bricks. Okay, those are Lego bricks, image, text, text, circle. And they're being packaged up to us, and we found out that it's a tuple view that it makes out of it. But we also found out we don't care what the heck it's called. And if ViewBuilder changes its mind and calls that thing something else in the future, we don't care, because we have the advantage of all this stuff being hidden from us, all right, all the view builder machinations. We never really look at what a view builder actually does. We just know it's a bag of Lego, and we hand it off to VStacks and HStacks and all the other powerful instruction manual views that you're going to learn about later in this quarter. And that made it so that our body is this VStack instruction manual view with that bag of Lego. We got this UI on the right. And it's a helicopter view called content view. Helicopter view meaning it's a combination of other views, obviously. And that's it. That's what we learned on Monday. And that is actually all there is to building views. It's just composing these views, more and more views, using VStacks and HStacks and other combining things, bags of Lego, putting them all together, and you build bigger and bigger things until you have a gigantic app. Now, speaking of the app, how do we know what our app is when we run? And we actually saw this briefly. I'm going to switch over here to another file, which is the CodeBreaker app. Here it is. I showed you this briefly when we were doing the tour of Xcode. See, it's got @main. This is our main program. Now, we're not going to worry too much about this. It's got a struct. Notice that that struct called CodeBreaker app behaves like an app. :app means it behaves like an app. We're not going to talk about what it means to behave like an app, but mostly it just means you've got this main piece of code right here. And then it's got some other stuff in there about scenes and window group. You see the var body is not some view, but it's some scene and window group. And this is really not a big deal, this kind of boilerplate on iOS, because we tend to have one window. It's the entire app. But on Mac, you have multiple windows. Multiple scenes, you'd have window groups. You see why you have this here. This is a multi-platform thing. But in either case, you get down to here, and this says content view. This is our helicopter view. This is why when we run our app, we see our helicopter, which is our little content view. You see that? And that's as simple as that. That's what determines it. And we also have that little word content view down here in our preview, and that's why it appears here on the right. If we didn't put that there, we wouldn't see it here on the right. So that's it. That's the entire summary of everything we did, and that's really the entire summary of everything there is to building views. Now, of course, I've only shown you a tiny fraction of the number of views that are in SwiftUI, especially the instruction manual views. You've only seen HStack, VStack, and ZStack. So there's a lot more to learn, but that's the basics. Right? Any questions about that before I dive into the next thing? The next thing is, we said the content view, our helicopter, behaves like a view, and we know we had to do var body, but I told you we're going to get a lot of cool features because of that. And you are. And that's because every view has hundreds of functions on it to customize the way your helicopter looks. Setting the colors and the sizes and the positions of things. And we saw those things actually in this library when we went here, this long list of hundreds and hundreds and hundreds of things that I scrolled through. And we are not going to learn all of these in this class. We only have 10 weeks. I mean, we'll get to 100 or 200 of them, hopefully. But there's a lot of stuff in there. And we're going to learn it by discovery. We're going to learn by doing. I'm going to start using them, and you're going to see me use more and more of these view modifiers. So how do these view modifiers work? Well, the view modifiers are just functions that are added to the view protocol. Remember, I told you the view protocol is just behavior. Okay, behave like a view, right? It's just behavior. There's not actually any code, any implementation with a view. But there's a very powerful mechanism that says, if somebody behaves like a view, here's a function implementation they can have. And we do that hundreds of times for Vue. So Vue has hundreds of these functions that Apple's written that work as long as you behave like a view. These view modifiers are just functions, completely normal Swift functions. So let's call one of them. What is the syntax for calling a function? Well, it looks like this. Let's change our greetings here to be welcome to CS193p. That's a little more fun, and we'll change howdy to greetings or something like that. We actually saw a glimpse of one of these when I was over here in the inspector. Do you remember when I was over here in the inspector and we were fiddling with these things and I changed the font and I put a line of code over there? That was a view modifier that I put in there, and this is the view modifier I put in. It's called font. So to call a function in Swift, you just say dot and then the name of the function and then parentheses and all of its arguments. And it can have any number of arguments. And these arguments can have little names like image system name. See, that's a named thing in the arguments to creating an image. Same thing with functions. Functions can have names. In fact, they usually do. But this one I'm going to show you, of course, it does not, but many do. So font, it takes one argument, which is the font that you want this text to have. And these list of fonts that are here you can find from the documentation, but if I start typing these fonts right here, I'll start getting help from Xcode. You see that? It's saying large title. If I back up here, maybe caption, call out, H is headline. You see, I'm getting some help there of what they are. And of course, I can go out into the documentation to get a complete list of these things if I look at the font struct. And so let's set one here. Let's try large title because it's easy to see. Now, as soon as I do that, look what happens to Welcome to CS193. You got large, as you would expect. So what actually happened there when I called font large title? Well, font large title takes any arguments it wants, in this case which font to use, but it also returns something. Anyone want to guess what it returns? Yeah, a view, some view. It actually returns you a modified text, a text that's been modified to have that font. And so our VStack, its little view builder, its bag of Lego, still only has 4 views in it. It has an image, it has a text that's had its font modified, a text, and a circle. Those are the 4 views that are in there. So it's essentially, we're using a different view by modifying it that way. And that's cool for a lot of reasons, but one of the really cool reasons is now you can chain onto that. I've modified this text to have this font. I'm going to modify it again. I'm going to use foregroundStyle. How about green? Look, it turned green. I have taken the text that I modified to have a large font, and I've modified it again to be foregroundStyle, and that returned a new view. So now, again, I have these 4 views in my bag of Lego here, an image, a text that's been modified to have its font changed, and then modified again to be green, and then a text in a circle. Those are the 4 views I have in there. And I'm going to be doing this all the time, constantly chaining these things and putting various modifiers on things to make things look the way that I want. Now, this line of code is starting to get long, and I have a lot of width here. I could probably leave it long, but we usually don't do that. We usually will put them one on a line each. It's just a little easier to kind of see what's going on and read things, and it makes it so things aren't so wide. So, text welcome to CS193p is kind of short, so when I added the things, it didn't go too long, but some lines of code are longer, and if you added those things, you'd be wrapping and it looks bad. So we do this almost all the time, this kind of manual wrapping as opposed to letting the editor wrap it. Now, this font, large title, it's something we get because text is a view. All views get font. And sometimes it doesn't matter, like, well, I'll go down here to circle.font, the large title. No effect, does nothing. That function does exist on Circle because Circle behaves like a view. It's a struct that behaves like a view, but it just does nothing. What about this one up here? Image.font.large title. Whoa, that made a difference. Did you see that? That actually made that globe larger. Just in case you missed it here, I'm going to take it off. It's a little small globe. Back on, it got large. Why did image change its size? Because of font. Well, these system images, like globe and like tree we saw before, they are often interspersed with text. And so if you're setting some sequence of text and images to some type, you want it all to stay the same. Notice that that globe is about the size of the capital letter W. The image is going to always kind of track about the size of capital letters in there, depending on the shape of the image. Some images are different shapes, but approximately. So it's up to each view how its modifications cause it to draw differently. But we're essentially, like our Lego bricks, we're saying, oh, I want a red brick or a green brick versus some other color brick, etc. I'm just modifying them to be how I want them to be. Now, here's an interesting thing as well. What about VStack? Is VStack a view? Yes. Can I do view modifiers on it? Absolutely. Let's try this. Okay, let's take some of these view modifiers off, these font modifiers, make everything back to being tiny, and I'm going to go to VStack and give it the font thing, font.large title. And watch what happens here. They all got big. Well, what happened there? Well, the VStack itself can't really do anything with font large title. It doesn't have any text itself. It has things in its bag of Lego that have text, but it doesn't. So it passes it on. And this is true pretty much all views. If you send something to them and they're container views, instruction manual views, or whatever, bag of Lego views, they'll pass it down into their things, unless they can deal with it themselves. So what's an example of a view modifier that a VStack could deal with itself and it won't pass down? Okay, I'll show you that one. Let's go to this text, welcome to CS193p, and I'm going to put another view modifier in here called padding. And look what happened. See how it got padding around it? It got extra space between the globe and the top, and between welcome to CS193p and the greetings. It got its space there. Again, I'll put it off and back on. See, kind of jammed up, padding around it. Well, what happens if I put padding on the VStack? Okay. Ooh, it put the padding all the way around, but it didn't put the padding in between. You see, if I take that padding away, there's still no padding on the individual views. They're just padding around the whole thing. So there's a case where the VStack got a view modifier to it that makes sense for the VStack itself, so it kept it and used it. And you'll just learn over time, and it usually isn't really obvious, which view modifiers are going to get passed on and which ones can make sense to these instruction manual views like VStack. Cool? And that's incredibly pretty much all there is. I mean, this is 90% of understanding how to build the UI you want is views and view modifiers. And even when we talk about sophisticated things like animation, which we'll talk about in week 3 or 4, animation is just all about animating the changes to view modifiers. That's what it is. That's what animation is, as simple as that. So everything kind of comes down to views and view modifiers. Yeah. Yeah, so the question is, what order are these view modifiers applied, which is really important, actually, because they're applied in the order you see them in the code. So if I went like this, text here, and I say dot padding, that dot padding is going to be applied to the text first, and it's going to be bigger. And then if I put another, show you another one here, dot background, yellow, you see, the yellow is applying to the padded part. It's not applying just to the text, it's applying to the padded part because I put the padding first. But if I take the padding and put it after the yellow, see, yellow now is only on the text, padding, now there's still padding around it, but it didn't get yellow because it didn't apply to it. So the order does matter. And that's great. You can use that to your advantage to kind of get things to look the way you want. All right? That's a great question. Yeah? Yeah, another great question. So the question is, what about the order of the modifiers that are coming in from the container versus the ones that are there? The ones that are closest are the ones that are going to win when you have the same modifier. So, for example, if I have font large title here, but let's say I go to this guy and say dot font dot caption, which is tiny. Look, the caption wins and the large title is ignored. You can kind of think of the ones that are passed in as a little bit like defaults. Right? The default font would be large title, but if you apply a font, it overrides it. Same thing with colors. Like if I said out here, dot foregroundStyle blue, everything's blue except for our little welcome to guy right there, which I'll make bigger so you can see it. He's still green with a yellow background because he sets his own foreground style to be green. That overrides. All right? So it's a really great system. It's really flexible. It's really easy to tweak things and tune things to get the colors and shapes and sizes you want. And there are a lot of view modifiers. Again, I'm not going to sit in slides and list them all and here's what they do. I think you learn them better when you see them in action like this, where you're seeing it happen. So we'll continue to learn them that way. Okay, that is it. That's all I wanted to talk about that. So now it's time for us to build our app, okay, CodeBreaker. So what is CodeBreaker? What is this app? Well, I actually brought, this is vintage 1970s game here that plays CodeBreaker. It's called Mastermind, you see? It's a game of cunning and logic, it says right here. And this is how Mastermind works. Let me get this one out here, too. I'm going to pass these around so you can feel them and stuff. So here they are. This is the game. It comes with all these colored pegs, right? A bag of these colored pegs. And then these little white and black pegs up here, too. Okay, so this is it. Let's see if can we see it on the screen there? I guess I have to be careful to hold this steady. So this up here is a master code. So this is a two-player game, and one person is the master code master or whatever, and they set a secret code and then they cover it up with this little plastic piece. And then the other person starts at the bottom here guessing what they think it is. And the only feedback that the code master here gives them is whether they got one exactly right, that's a black peg, or whether they got one right but it's in the wrong spot. Okay, that's a white peg. So let's look at this game and how it was played. So the first time, the guesser guessed all yellow. Okay, I guess it was, and there's no yellows up here. So they got no pegs. Okay, there's no pegs in this spot here. Then they went, okay, blue, blue, red, red. Well, the red is an exact match. This red right here matches this red, so they got one black. This blue, though, one of the two blues matches this blue in the wrong spot. So it got one white. So you got one black and one white. Right, and then we go up to the next level. Here he went all green, and of course two of them are right, so he got two black ones and no white ones. See how that works? And you just keep doing this with getting this feedback until you get all black and you've guessed the whole thing. Or, in this game, you get to the end and then the code master wins. He wins the game in that case. And the faster you guess it, I guess you get more points or whatever it is. Okay? So this is the app we're going to be building. And you can already imagine how we're going to build this with views, right? We're going to have colored circles, both for these little pegs and for these ones up here. We're going to have a bunch of them. And we're going to do all kinds of fun stuff. Put this in the scrolling view and doing all kinds of great stuff, okay? So this is what we're going to be building. All right, so let's get rid of all this template code that we've been playing around with and start with how we're going to do this. So let me ask for a volunteer. Let's say we want to do the colored pegs. Okay? Does anyone have a suggestion how we're going to do the colored pegs, the 4 colored pegs? Circle? Absolutely. Let's do a circle. I'm going to put a circle on here. Circle, actually. And we need 4 of them, right? So let me put 4 circles on here. Okay? That's okay. We're making progress, yeah?
H-stack?
H-stack. I love that idea. Okay, let's go over here. H-stack. Put these things in an H-stack. That? Ooh, that's already looking almost exactly like that game. And then, of course, the pegs are colored. And these are black. So let's put some colors on here. So let's put the colors on there. We know how to do that, right? Foreground color for foreground style. There's also another view modifier called foreground color you can use. But foreground style is a little more powerful. It can do things like gradients and other kinds of things to have control the foreground drawing of your thing. So here we'll do red. And I'll just use copy and paste to make some more ones here. Paste, paste, paste. Maybe we got green, another green, another yellow or something like that. And we'll continue our paused preview over here. There we go. That's starting to look pretty good. And maybe we want some padding around it because we don't really like it jamming into the edges there. So let's put a padding. It's H-stack, padding. And, of course, looking at that thing, you see that there's multiple attempts, right? So we need that. So how would we do that? How would we have multiple attempts here? A V-stack, absolutely. And there's no reason that the V-stack can't have all these H-stacks in it. So I'm copying that and going V-stack like this. And then I'm just going to put a whole bunch of them in there. And then get the curly braces right here. Oh, one thing that's cool, too, is when I type the closing curly braces, it'll usually adjust your code to have the right indent. So there we got 4 of those. And of course now I could go and change this to blue, and change this one down here to red so that they're all different. But I clearly wouldn't want to write my code like this. Okay, this is kind of ridiculous. All this copied, pasted code. Anytime you find yourself copying and pasting in any programming environment, certainly here too, you're probably not doing it right. Okay, you don't want to copy and paste. Copy and paste usually means, oh, I need a function. That's why we have functions to do things like that. So we want that here. We want some kind of mechanism to make it so that we can have this thing repeat without having to copy and paste this huge V-stack or whatever. So how do we do that here? Well, I'm going to show you a couple different ways to do that, to essentially have functions or ways to repeat things. I'm going to take this H-stack right here, and I'm going to cut it out of here. I'm going to create another var. Just like I have var body, I'm going to call this var pegs, because it's going to be my pegs. And it's going to be some view. In fact, it's going to be that H-stack. Okay, so I just took that H-stack, copied it up from down there, and put it in pegs. And of course, now, instead of having all this, I can just do pegs, 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 as many pegs as I want. Okay, that's just a variable, and it's computed. It's a computed variable, so every time I put it, it gets called, the code down at the bottom, and I get one of these rows, and I'm putting it there. And I can put as many of them there as I want. So that's one way to do this. Now, what we're doing here is called decomposition, okay? Because we are taking a big view that had all kinds of H stacks in it, and we're decomposing it down into smaller pieces, right? And we really want to do a lot of decomposition in SwiftUI. I cannot overemphasize enough how you want to have small little functions, not gigantic things with H stacks inside V stacks inside Z stacks. There's two reasons for this. One is it gets kind of hard for your reader of your code to understand what you're doing when you're going that deep, but also the compiler has problems with that too. Okay? There is one thing that's going to frustrate you in this class. I'm going to tell you up front. If you have gigantic var bodies, sometimes your compiler will just sit there compiling for minutes sometimes, or certainly 30 seconds or more. And whenever you see that happening, it means you have a syntax error somewhere, you've made a mistake in there, and it's just can't figure out what's going on. And it has to do with kind of how View Builder works, but it's having to explore every pathway that could possibly be a valid View Builder in there. And it takes a long time. And eventually it might spit out the error that says, the compiler just gave up. It took too long. I tried everything I could. I couldn't figure it out. I don't know where the error is. But if you decompose, then it's going to be able to find the error rather quickly because there's less pathways for it to go. So decompose, decompose, decompose. You want a lot of decomposition. But there's a problem with this kind of decomposition is that pegs is the same four colors, red, green, green, yellow. So I can only make that. And we know that in our game, we can obviously attempt different things each time. So we have to have some way of doing that. So another way to do this decomposition, instead of making this be a var, is to have it be a func, because then we can pass arguments to it. Okay, we can put some arguments. Now, the only difference in syntax there is that the func's return value, we use arrow, whereas a var body, we just have colon of the type. We like this arrow because it's like, this comes out of this thing, right, in this direction, out. Okay, so that's just a syntactical thing. And now this is a function, maybe we could pass an argument in, which is the colors to use. So I'm going to do that by adding a parameter here. I'm going to call it colors. And the way we have arguments in functions is that we give the name of the argument and a colon, and then the type. And you can see that the AI, pretty smart, it knows we got a lot of colors in there and probably want an array of colors. And the way it's writing that, open square bracket, color, close square bracket, that does mean array of colors. But I'm going to write the array of colors in a little different way. Array, which is the type, angle bracket, color. This is the same thing as that square bracket color thing that the AI was trying to do there. But this is just a little clearer what's going on. The type here, array, is a struct. And it's a kind of struct where the things it stores is configurable, parameterizable, we would say. And this is the same in other languages, right? Java has this. We call these generic types, types that can have parameterizable parts to them. And an array, it makes perfect sense. You want to have an array of things, but you don't care what they are. And the cool thing is that one implementation of array inside Swift can handle an array of anything. But you have to say what it is. Now, why do you have to say what it is? Because Swift is strongly typed. I already mentioned this before. There's no fuzzy types and this, I don't know what this is. No, every single thing is very strongly typed. Even that tuple view thing wasn't just tuple view. It was tuple view with an image and a text and a circle, right? It was super specifically typed. Same thing here. You can't just say, oh, I'd like an array of stuff. No, you got to say array of color. Okay, you have to be very specific. So that's what's going on here. So I'm going to pass an array of color here. Notice that the AI also wants to say equals empty array. If I called pegs with no arguments, that would be the default value. If I don't do what the AI wants, then when you call pegs, you have to provide this colors because no variables in Swift cannot have values, and this is a parameter. It has to have a value. So you're forcing the caller to provide the colors, which is what we want. It makes no sense to default. No, a pegs with no colors would just be nothing. Okay, so it makes no sense. All right, so that's how we call a function. So you can see that we now have errors up there because pegs is no longer a var, it's a function. So we're calling a function. We have to provide the arguments to the function. AI is suggesting. How about colors? And look, when I press tab, it even has a thing that you can click on or tab to that's kind of trying to tell you what this is. It's an array of colors. So I can type it. So let's type an array of colors here. How do you type an array in Swift? Super easy. Open square bracket, and the things in the array, close square bracket. So let's do that. Open square bracket. Let's try red, green, green, yellow. So there's that, and I'll copy and paste to do the other ones. Get rid of these bars. Change these a little bit to make sure that our code is actually working. Yellow, blue. So we've got this pegs, and we're calling it with different colors. Of course, it's still not doing anything, because if you look inside our implementation of our pegs function, it's still red, green, green, yellow, which is what we're getting. So we need to take the colors out of this array of colors that was handed to us and use it to draw each of the things. Really easy. This is how you get something out of array. You say the name of the array, open square bracket, and the index into the array. So color sub 0. Now our color sub 0 is red in all of them, so that's not really helping us much. But let's try colors sub 1. Oh, look at that. Green, blue, yellow. And up there, green, blue, yellow. So that's working. And we'll do that with the same ones here. Colors sub 2 and colors sub 3. All right, yes?
How would you error check to make sure that the array has the right number?
Yeah, let's look at that. Let's look at that. Let's go and change one of these to not have the right number. Okay, this one right here, I'm going to delete this blue, so it only has 3. And let's just see what happens. Get rid of blue. Uh-oh, wham! Ah! What happened there? Okay, I mean, it did not like that at all, right? My preview went black with this red X right there. It says it quit unexpectedly. That's the process behind the scenes that's doing that preview thing there. And if I click ignore here, which you're always going to do when this happens, by the way, then I'm kind of like, I have nothing. I don't know what's going on. When this happens, preview dies like this, now you want to use the simulator. Because when you run this in the simulator, it's going to crash, but it's going to show you the exact line of code and the back trace of what happened and the error message and all that. So let's do that. Let's run this in our simulator. Just hit play up there in the upper left. Here we go. Oh, it's gone, okay, because it crashed. But look at all the information we're getting here now. You see this red thing, thread 1, fatal error, index out of range. So that's what happens. When you index into an array outside of its bounds, that's a crasher in Swift, always. You have to protect against it. We'll look at how we could do that in a second here, yeah?
Is there a reason why we have a period before every color? Green.
The question is, why is it .red, .green, .green, .yellow? You know what? I'm going to take a time out and answer that question right now. And we'll get back to the error here. It's going to wait for us while I do this. But what is going on here? Why is this .red? Why can't I just say red? Well, what's really happening actually here is that this fully named is color.red. Color is a struct in Swift, just like font is a struct, and it has these variables like red and green and yellow defined on the type itself. These are called static vars. So these vars are not a var that you would find in a color. They are vars on the color type, the very color type. So you can kind of think them actually as global variables that are namespaced to color. See how I've namespaced it? I said color.red. I've put this .red in the namespace of color, but it's essentially a global variable. And if we go look in the documentation, so I'm going to do that trick where I hold down Option and get the question mark and then click on color. And then we go down to the bottom here and say, go to the documentation. Here it is. Oh, in fact, here's color right here. And towards the bottom, it says getting standard colors. You see all the static let, this, let orange, pink, purple. These are all the colors that are built in. And that word static means that this let, this var, did I explain let, what that is? Let and var are the same thing. It's just that let means read only. Var means variable. But otherwise, they're interchangeable. You use them in the exact same places. Now, why then, back here, do I not type color.red, color.green, color.green, color.yellow? Well, first of all, that's a lot of typing the same thing over and over. And number two, it's because you have this really strongly typed language, Swift. It's a pain to be constantly typing the names of types, because types have to be so explicitly just said and determined all the time. So Swift does something for you. I don't know if I mentioned this one before, called type inference. Infer the type based on the context. In this case, we're passing colors. It's an array of colors. If I type .red, Swift is like, oh, you mean color.red, okay, because this is an array of colors. So it's able to infer that that's color.red if I leave the color off, you see? So that's why I end up with .red. The same thing was happening when we did fonts. Remember I did .font, .large title? That was actually font.large title. Yeah.
Like there's no other system variable like .red, and so that is it has to be a color.
Yeah, so the question is, does the inference only work when Swift actually knows that these are colors, or could it somehow look around and see, oh, there's nothing else called red, so I'm going to use this? And the answer is the former, not the latter. It has to know the context of the types. But since everything is strongly typed, it always does know the context of the types, so it always works. Yeah, question? So the question is, could I just use a for loop or something here that would use all of them? That's what we're going to do. We're going to do a for loop. But first, let's take a quick look at the environment that happens when we get an error. We get this red index out of bounds. I think that's 100% obvious to you what's happening there. But on the left, notice the navigator popped out, and it showed us how we got here. So we can click back up the change and see that we are in an H stack and that it was called from this pegs. So we can kind of see how we got to where we are. And the debugger is fantastic. And this is when you click on each stack frame, you know, you're only going to see the variables that are there. And most of the time we interact with the debugger down here in the lower right. See it says LLDB. And we are going to type commands like print things out. We can even set variables to have values right as we're running. And I'm not going to get into the debugger right now because I want to get started on CodeBreaker, but it's a really great debugger. Even having said that, though, you'll be using print statements a lot. Print statements print out to the console also. Both of those things have their values. All right, so when you figured out what it is, what this problem is, you go up to here and you see what that is, then you're usually going to hit stop. Because stop is going to clear out your navigator, take the red away, and now you're back to editing your code. How could we protect against this crash? Well, you know that inside of a view builder like this is a view builder, right? I can do ifs. So I could say if colors.count, ooh, look at AI, got it for me again. If colors.count is greater than 3, then show this one. And I guess I could go here and say if colors.count is greater than 2, got that one right too. We'll put both of these in there like this. Okay, we could do this. This is how you fail this course when you write code like that. Okay, that's horrific code. You would never want to do it that way. But you can do it. And I'm really showing you this more just to show you can put ifs in your view builder. That is the one thing. There's only two things besides a list of views that you can put in a view builder. One is ifs. The other one is lets. So you can have like little local constants or whatever. So I guess there's nothing, a switch statement, which is like an if, a multi-if. But that's all you can do in there. So we could do this, but of course we're absolutely not going to do this. We're going to do exactly what she suggested, which is we're going to do a for loop and just go for loop through those colors and show them. But unfortunately, view builders, no for loops. You can't do for loops inside view builders, only ifs. So what are we going to do? Well, we are actually going to use another bag of Lego view. We know about one bag of Lego view. It's that tuple view thing that View Builder builds. But there's another kind of bag of Lego, which is a for each bag of Lego. And what a for each bag of Lego lets you do is give it an array, like this array of colors, and it's going to build a view for each of those colors. And then it puts them in a bag. Make sense? So like here, we could for each over these colors, and it will build a view for each color. It would be a circle with that foreground style, and then we would have a bag of 4 circles. And then we hand that off to the H stack, and it shows it to us, right? Pretty obvious. So let's take a look at for each. It's a little trickier than I just said, but here's how it works. It's just a view. A for each is a bag of Lego view, so it's a view. It's called for each. And for each takes 3 arguments, basically. It actually can take some other arguments, but fundamentally it takes 3 arguments. The first one is the array of things you want to do something for each of. In our case, you would think that would be the colors. And I'm going to start out with that, but we're not going to end up with that, but that's what we're going to try to do. The second argument is a variable, the name of a variable that for each can call on the things in your array to get a unique identifier for it. Now, why does for each need a unique identifier for everything in the array? Well, one of the primary reasons, animation. Because as the contents of the array is changing, you're adding, removing things to that. We're not going to do that, but if you were doing that, you'd want those changes to be animated. You want the views moving around on screen. Well, for each to know what's going on when that contents of the array is changing, it needs to be able to know which ones are which, because it builds these views, one for each of them. It needs to keep them hooked up. So can you all buy the assertion here that for each needs to know a unique identifier for each of the things in the array? Otherwise, it just can't keep track of what's going on as things change. So how do we do that? Well, it's got this argument called ID, which means what is the identifier. And then you're going to go backslash dot the name of a var that is on a color in this case. It has to be a var, something in the array right there. Now I'm going to use the var self. Self is a special var that every struct has, which means it's self. Now this is not going to work. Why is this not going to work right here? Can anyone guess? Yeah?
They're not unique.
You're not unique. That's the problem. Look at red, green, green, yellow. Uh-oh, 2 greens in there. For each can't tell which view goes with which green. And like if one of those greens left the array, which view does it take away? It doesn't know because it's not unique. Those 2 greens look the same. So that's the problem. Our colors is not unique. If our colors were unique, if we force them to be unique, this would be fine. But they're not unique. So what is unique about this colors array? How can we have a unique identifier for each one? Well, I'm going to use this trick, which we use a lot, which is the indices into the color. So indices is a var on array that gives you a collection, an array basically, of the indexes. So if you have an array with 4 things, it's going to give you an array with 0, 1, 2, and 3 in it. So you're going to get an array. Essentially, it's actually something called a range, but it's a collection of things. So now, ID self, that is unique. Because if I have an array with 0, 1, 2, and 3 in it, those 4 things are unique. And then I can just use that index to go look in the array and get the color I want. Does that make sense? All right, so we do that a lot. And then now we got this third argument. This third argument to this is the same as a VStack. Content, you see, it's trying to help me here. It's the content thing. Now, this one's a little weird, though. It's got index in. Okay, index in. VStack didn't have that. What's that? Well, that's, of course, the argument to this function that needs to build a view that says which one. It's asking me here to build a view for each of those colors. Well, it has to tell me which one it wants me to build the thing for. So that's what index is. The in is just a keyword that separates the argument name, index, from the code. And we're going to see exactly why this looks like this inline function having this index in later in this lecture. So inside of here, and again, I'm going to use trailing closure notation here. Okay, watch carefully. I'm going to take that content and get rid of it. Put the parentheses here instead of here, and have that thing hang off the end. All right, now inside here, I'm just going to make a circle for that color. So circle, foreground style. Look, AI, added again. Got it exactly right. Color subindex. I'm just going to take the index because I'm for eaching over the indexes now, and then get the color for that. Everyone cool with this? Let's get our preview going and see if it works. Oh, it didn't work. That's because I didn't take this out. Get rid of that. Or bad code. Yeah, look at that. And even our 3 didn't crash. Our 3 just showed 3 because we're for eaching over the indices, and that array only has the indices 0, 1, and 2. So it only showed those. And we can do that with all these. Let's do your thing of having 5. I'll say comma.blue. Wham. All right, so let's go back to having 4, 4, and 4 here. This guy, blue. All right, we're making good progress here. What's next in our little game that we have there? We got those little white and black pegs, right, on the side. So those white and black pegs, they're, has everyone got a chance to see this, by the way? Has it made its way around? They're in a little square, right? It's 2 by 2. How would we build a 2 by 2 square, do you think? Like what code would we write to build a 2x2 square of circles? Yeah? Exactly. We're just going to make an H stack with 2 V stacks or a V stack with 2 H stacks. That makes a square. And there are other instruction manual views for doing grids, okay? But we don't need anything more sophisticated than 2 H stacks in a V stack or 2 V stacks in an H stack. Either way, it's the same thing. So I'm going to do 2 V stacks in an H stack, okay? I'm inside this H stack. This is the H stack that's showing these 4 things that come out of the bag of Lego, the for each bag of Lego, right? So I'm just going to add another thing to that H stack. Remember that the argument to an H stack, that content, is itself a view builder. So it's perfectly fine to have 2 views listed there, a for each view and an H stack. That's what I'm going to put here, a for each view and an H stack. Those are the 2 views that I have here inside this other H stack. The for each is itself a bag of Lego. So when you put a bag of Lego view, like for each, into another bag of Lego view, the H stack's bag of Lego, it breaks the bag open and looks in there. So we're going to have 5 views in here. The 4 that come out of the for each bag of Lego, and then this H stack that I'm making that's going to have the little pegs. So let's do that. H stack, and then a V stack, and then circle. And another circle. I'm going to use copy and paste here because this is bad code. You're going to see we're going to make it better code soon. And look at that. That worked great. Okay, now these are all exact pegs, right? Pegs where they're black pegs that it was exact. How would I make those pegs not be exact? Well, we're going to learn another kind of modifier here, which is a shape modifier, because circle is a shape. Okay, and there are other shapes. I'll show them to you in a second here. Actually, I'll show it to you now. Here's another shape. We got circles for the things. How about if I made this a rounded rectangle? A rounded rectangle takes a corner radius as an argument. And now, look, we have rectangles. That kind of doesn't look very good, but what if I wanted squares? Okay, unfortunately, there's no square. There's circle, and there's rounded rectangle, and there's some other ones, capsule and stuff, but there's no square. So how could I make this a square? Well, I'm going to do it actually with a view modifier. So rounded rectangle, which is a shape, it behaves like a shape, and is also a view, behaves like a view, so it's both. So I have lots of different modifiers I can put in it. And one of the things that, since it behaves like a view, we can do is aspect ratio. So aspect ratio will set the aspect ratio of this view, no matter what it is. Rectangular or whatever, it's going to set that aspect ratio. And it takes the ratio, so I'm going to say 1 to 1, which would be square. And it takes another argument here called content mode, which is either fill or fit. Fill or fit. Fit means make it this aspect ratio and fit it in the space provided to you. Fill is make it this aspect ratio and use all the space provided to you, even if that means you spill out over the space. Like, let's say your aspect ratio is rectangular, 2 to 1, but you've been given a 1 to 1 space. Then that view is actually going to draw outside its bounds. And in Swift, drawing outside your bounds, perfectly allowed. Now, that might sound like a crazy design point on their part that you can just write all over the screen outside your bounds. And of course, there are view modifiers that say keep inside my bounds. But it was a great decision on their part to make it so the views, they have their little drawing space, but they're allowed to draw outside if they want. And so we don't encounter that much, but they can. But look what happened when I said the aspect ratio of 1. It turned into a square, because squares are a 1-to-1 aspect ratio. And this actually looks kind of good. Maybe this is the way I want my game to look, even though it looks different than the mastermind version there. Back to circle down here. So it's a shape. Shapes have a few extra modifiers that views don't have. One is .fill, and .fill can take a color, like color green or something like that. And look, we've got a green filled right there. It turns out .fill is the default. If you don't specify a modifier, that's why the rest of them are black, right? And the default foreground color here is black because we haven't set. It's not quite black, but it's turning out black here. And then what about the little pegs there that are white? So for those, I have a white background, so I can't really use white. So I'm going to say white, but with a line around the edge. And I can do that with a little shape modifier called stroke. You see, it's already starting to do it here. Now the AI wants to make it green because I made the other one fill green, but I actually want this not to be green. I'm going to have it be whatever the default color that's going on. And there's the line width right there. If I specify a color here like color.black, line width, that's good. You see, that's working. But this could have problems. Let me show you a problem with making that black. Let's go to this button right here. You see this little button? Okay. Remember, this is the run mode of the preview. This is the select mode where you can select things. This one right here is kind of like the select mode, but it lets you change various things about the environment in which this app is running, like color scheme variant. So this is showing dark mode and light mode. And if you look in dark mode, my round circles don't work. You see? Because they're drawing black edges around something that's otherwise not filled, and the black is on a black background. So there's other colors, kind of special colors that are built in that we can use to fix this, like there's one called primary. Primary is the primary color for this mode, dark mode or light mode. And this, look, it works on both because the primary color in dark mode is white and the primary color in light mode is black. Yeah.
When you add a stroke to a shape, does the line width go beyond so say in the case of the circle, does it add to the radius or is it the same radius?
What a great question that is. I mean, the question is, when I stroke, is it stroking like on the line, the edge of it, such that it's kind of spilling out a little bit? And the answer is yes. And so you might then ask the question, okay, well, how do I make it go inside? And there's a different view. This is a view modifier called stroke border. So stroke border means stroke this thing and stay on the inside. But look what happened to my UI when I used stroke border. Everything got a little spread out. And why is that? That's because the stroke border caused it to turn into a view, and it lost its 1-to-1 aspect ratio that a circle had. So if I really want to use stroke border, I would then have to say aspect ratio 1, content mode fit, goes back to working. But that's a really good question. And I'm actually going to use stroke border because I think it's better for it to stay inside. I don't like if it got near an edge, I don't want it to be slightly off screen or like something like that. So stroke border is better. But stroke border is a view thing, not a shape thing. So it loses its aspect ratio.
The black is turning into white on dark.
Okay, because when we did fill, see, we did fill color green. Down here, we didn't specify what fill to use, and so it used the primary as a default. So we got that from that. And in fact, if I take this green off, we're going to get that thing going in white as well. You see? Yeah.
So what is the ratio of like height to width?
It's width to height. So if I did aspect ratio 2, okay, that would be twice as wide as it is tall.
0.75 for the 3x4.
Yeah, exactly. So the question is, could I do 0.75 to get 3 to 4? Absolutely. And I could even type it like this, 3/4, because it would do the division right there, 3 divided by 4. So I'm getting 3 wide by 4 high on all my things there. All right. Now, there's another thing, though. What about when there's no peg? Because sometimes I guess, and I'm just completely wrong, okay, and there's no peg there. How are we going to show no peg? Well, you might think, okay, well, let's just put an if around it. If false, okay, if that peg's not supposed to be there, go like that. But, that doesn't really do what we want, because we want that to be 4 little pegs. I mean, this is not too bad. We could probably go with this, but I kind of want all the pegs to be in that same 4 square. So how would I have one of the pegs just like be there but not appear? I'm going to do that with something called opacity. Okay, so this is another view modifier. I'm going to say opacity 0. That means completely transparent. And opacity 1 means completely visible. And opacity 0.5 means halfway see-through. And opacity actually works. If there were something behind there, we would see it. See through it a little bit in this case. Or if it's opacity 0, we would see completely whatever was behind here. Given these 3 things, stroke, border, and opacity, and then just nothing, which is fill, I can show all of the little peg states. Right? You agree with that? All right. So the problem here now I have is that my little thing down here only shows this peg state, 2 exacts and 1 inexact. So how do I pass in an argument, or how do I make it so that this is showing different things? Well, before I solve that problem, I'm actually going to do some decomposition, because this is going to be kind of a long function, pegs. And this is a natural point of decomposition right here, to take this thing and put it in its own space. Now, the kind of decomposition we've learned so far is like func pegs right there. Create a function with the return some view. But I'm going to show you a different kind of decomposition, which is to make a new helicopter view. We're going to make a new helicopter view, which is these match markers right here. I'm going to cut this out of here, and I'm going to go down here, outside of the curly brace for this struct view, and I'm going to make a new struct view. Struct, I'm going to call this struct match markers, because that's what it is, and it is something that behaves like a view, right? That means, of course, it needs to have a var body, return some view, and it's going to be this thing. That's quite a suggestion there. It's going to be this thing that we had above. So now I have a new view, a new helicopter view. It's match markers view, and it shows that. And so I can call it just like any other view. All right, we put that match markers there, and they appear. So we've decomposed this down into its own view. Does that make sense? Would we keep this here in this file? We might. I mean, match markers are a pretty small little view. We might keep it here. But just to show you how you do it, let's move it. All right, so I'm going to select it all. This is really kind of cool feature. Select it all, and I'm going to cut. First of all, open the Project Navigator. Don't forget to do this step. And then I'm going to say File, New, Match Markers from Clipboard. Okay, it knew that I cut something that was a struct something view, and so now it's going to create a whole new file and put this in there for me. But I have to be in the Navigator when I do this. So there it is, match markers. Here's our match markers. It's complaining about view because view is in import SwiftUI, right? So we have to add import SwiftUI. And now we have match markers, and everything works. Okay, we go back over here to content view. Let this thing have a chance to recompile and build. And let's go back even to active mode, and there it is. And it's working. Match markers is working, even though it's in another file. We don't care. Now, one thing that's different about match markers, though, look here. How come I don't get a preview of match markers? So, right, there's no preview over here. Well, anyone know? Exactly. I need a hash preview down here. So I'm going to go down to the bottom and say hash preview. And I'm going to say match markers. And now, I got my match markers. Okay? That doesn't look that great. It's not really in context very much. We're going to fix that in a second. But at least I'm getting a preview there. We've got 10 minutes left. We're going to have to really hustle here. I want to make it so that this match markers, though, is showing markers that match the pegs. Right? I want to be able to kind of pass some kind of argument in or something back here in my content view so that I can say what matches are. So how am I going to do that? Well, I'm going to create a new kind of data structure, which is an enum. So an enum is an enumeration. I'm going to call this one match. And it's kind of like a struct in a way, except for it has no stored vars. Instead, it has cases, unique cases, like nomatch would be one case, exact would be another case, inexact is another case. I'm just making up the cases. So anytime you have a data structure which is uniquely one of 2 or 3 or 12 things, then you're going to use an enum. And you can have functions in this thing, perfectly allowed to have functions that are operating on those things in some way. You can even have vars, but they have to be computed. You can't have vars that are storage. The only storage that comes in an enum is its cases. Any data goes with the cases, so no vars. So I have this little match. And in fact, let's even put our friend match over here with our match markers. It kind of goes with these. And what I'm going to do here is I want in my content view to be able to say with my match markers, here are the matches to use, dot exact, dot inexact, dot nomatch, another exact, something like that, an array of matches. This is how I want to pass them in there, right? And they'll be depending on what my colors are and what's going on. And you can see that it's got an error here, and that's because we don't have an argument to match markers, and so it doesn't even know what dot exact is. It doesn't know that that's match dot exact. It can't infer that because there's no such thing as matches. But we're going to add an argument to match markers. So how do I add an argument to my own helicopter view? I got a helicopter view. I want it to take an argument. How the heck do I do that? Well, this is how you do it. You just say var matches is of type match. And because the rule of Swift where variables always have to have a value, no one's going to let you create match markers without providing those matches. So you've just created an argument to creating your match markers. If I go back here to content view, look, no errors now. Because it's like, oh yeah, you do it. And if I took this away, get rid of this, now it's going to say, missing argument parameter matches for match markers. Yeah.
So like, why do we like explicitly say array here?
Yeah, great question. So over here in match markers, she's saying, how come I'm not saying array of match here? And the answer is, that's exactly the same thing. Open square bracket match, close square bracket, and array of match are the same thing. They both mean the type array of match.
What's like best now?
Yeah, what's the best practice? The question, I think that I like this, but I'm a teacher. I think this is best practice. This is what people do. I have to be honest, that's what they do, even though I like array match. I think it's clear. But anyway, this is what it is. So now, when we create our match markers, we are getting the exact, inexact, and all that stuff that we need to show our markers. So let's go back into match markers and write some code that uses this matches stuff to do it. Now, by the way, notice this broke our preview, because now we have to provide this argument to our preview as well. Matches, colon, dot exact, etc. We'll let the AI do its thing here. So now I have to actually be a programmer and have a strategy. And here's my idea. And there's probably other ways to do it. But what I'm going to do is I'm going to count how many exact matches are in that array. And I'm just going to keep drawing dots that are black until I draw that many dots. Then I'm going to count how many total matches are there, and then keep drawing dots with white until I run out of that. And then I'll just draw opacity 0 at that point. So that's how I'm going to do it. And the way I'm going to do that is with a little func. I'm going to call this match marker. And it's going to take the index of which peg I want to draw. Not an index into the array. Maybe I could call this peg number or something like that. And so when it's the 0th peg, it's only if we have at least one exact, it's going to do an exact. If we don't have an exact, but we have at least one inexact, it'll draw it inexact. And if there's no matches at all, then it will draw it completely transparent. So I'm going to do that for each of the 4 pegs. And that's just going to be an int, 0, 1, 2, 3, 4. And then this is going to return some view, which is going to be a circle with the right opacity or stroke border, you know, all this stuff up here. In the VStack, instead of having these kind of fixed ones, I'm just going to say draw match marker peg 0, and then match marker peg 1, and then I'm going to do the same thing down here and do 3 and 4. Okay, 3 and 4. So this is my strategy for doing it. So all I need to do, see, they're all drawing as black circles now because match marker doesn't do stroke border or anything anymore. It just says circle down there. So I need to have this down here return a different kind of circle, or really the same circle but with different modifiers on it, depending on how many exacts and inexact I have. So I'm going to create a new variable here. I'm going to make it be a let, because remember, let is like var, except for it's a constant. I'm not going to change it. I'm only going to calculate this once, but I'm going to calculate the exact count. And it's going to be an int. And I'm going to do this in a way that's going to make you go, what? But it's really cool. And then at the start of next lecture, since we're running out of time, I'm going to explain in detail how this line of code will work. It's very important to understand how this line of code I'm going to write, which the AI is totally messed up, is going to work. It's really, really important. So let's go here. Exact count, I'm going to say it equals the matches array. Please count for me where, and I'm going to do a little thing here, match in match equals dot exact. This line of code, believe it or not, counts how many exact matches are in the matches array. And it's using functional programming. We're calling the function count there on matches. This argument there is called where, and that's a function. that function that you're passing takes one of the things in the array and it returns a bool whether to count it. The syntax of this is what we're going to go over in detail at the beginning of the next lecture. So that's the exact count. And then I'm going to do the same thing with the found count. In this case, though, it's where the match is not no match, does not equal no match. So now I have both of those things. And now I can say, let's do fill if exact count is greater than the peg. Then I'm going to use color.primary, otherwise color.clear. So color.clear is a really cool color that you can use to draw nothing. And then for stroking, I'm going to do stroke border. And again, I'm going to say if the found count is greater than peg, then I'll use color.primary, or I'll use color.clear. And I'll even do a line width here again, line width 2. And of course, I need my aspect ratio of 1, content mode fit. Okay. Now, this still has an error. It says function declares an opaque return type, some view. Opaque return type means it's type that has to be an actual type, but I can't figure it out. But it doesn't return it. And that's because I need to return this circle. Or what's another thing I could do to make that work? I can make it a view builder. I could put @view builder because then it would be a list of one thing, but at least it would return, right? So I can do either way here. I'll leave that return a circle just to show you that it's possible. And did it work? I think so. Look at our preview down here. It says exact, inexact, no match. Exact, inexact, no match. Okay, my great code worked. And if we go back to our content view over here, doesn't seem quite right. Is that right? Doesn't look like our inexact built right there. Oh, you're right. 0, 1, 2, 3. 2 and 3. Good catch. There we go. So now it's working over here. Okay? All right. So again, we ran out of time here. First thing on Monday, I'm going to explain this whole exact count thing right here, this functional programming, because functional programming is so important to Swift. And then we're going to dive right into doing the logic behind playing this game.